VFR flying, you can look outside and instantly see if the airplane is pitching, banking, or drifting away from where you originally want it. But in IMC, you don't have that original picture. You're relying on your instruments, your scan, your trim, and the airplane's natural stability. So when your examiner asks about stability, you don't just say the airplane comes back. There are actually two parts you need to understand, which is static stability and dynamic stability. Let's say you're flying straight and level into the clouds, trimmed up, and then turbulence bumps the nose up. The question is, what does the airplane initially want to do? Does it start moving back towards its original trimmed altitude, stay where the bump put it? Does it keep moving farther away? That first tendency is static stability. Positive static stability means that the airplane will tend to return towards its original trimmed condition. Neutral static stability means it tends to stay where the disturbance put it. Negative static stability means it tends to stay away from where it started. So for instrument flying, positive static stability is important because it reduces workload. If you get bumped into turbulence, the airplane naturally wants to start correcting back to where it was, instead of immediately making the situation worse. Dynamic stability is what happens after that first reaction. So we're looking at the airplane over time. After the disturbance, does the motion slowly calm down? Does it keep oscillating at about the same size? Or do the oscillations get better? That is dynamic stability. Positive dynamic stability, the oscillations get smaller over time and eventually die out. Neutral dynamic stability means the oscillations continue about the same size. Negative means they get bigger over time. In instrument flying, this is really important because you're just trying to maintain a stable platform. If the airplane is trimmed properly and is dynamically stable, all disturbances are easy to manage. Out of trim, over-controlling, or chasing every instrument movement can actually make those oscillations worse yourself. So what's the easiest way to remember it? Static stability is the first reaction, then dynamic is what happens next. And here's what you all want, the Checkride level point. An airplane needs positive static stability before it can have positive dynamic stability. Positive static stability by itself does not mean the airplane is dynamically stable. So for instrument flying, don't think stability as an aerodynamic definition, more a part of workload management. Stable, properly trimmed airplane gives you time to scan, interpret, and make small corrections. An unstable, poorly trimmed airplane is instrument flying harder than it needs to be. So if your examiner asks you about stability, a clean answer would be static stability is the airplane's initial tendency after a disturbance. Dynamic stability is how an airplane behaves over time after that disturbance. On instrument flying, positive stability and a proper trim help reduce workload and make it easier to maintain precise aircraft control without outside visual reference. If you have your instrument rating coming up and you're freaking out, don't stress. Go to the link in our bio. Check out our Checkride Study Guide Instrument Pilot flashcard deck, created by CFI, trusted by over 18,000 pilots. Or make sure to follow us. We post study tips and tricks like this all the time.